Well, thanks for coming, and I thought I'd just do kind of a demo and go through each step, kind of talk a little bit about how I'm doing things, why I'm doing it the way I do it, and such. So, you know, when you get into clipper blades, you have the choice of doing them manually or, you know, with mechanical arms. And we sell our machine both as a manual machine or mechanical arms. So how many of you are like considering getting into it? And you haven't done it before, and you haven't.
I'm still learning.
You're on
a lot.
I need money. Okay, well, I don't want to bore you with all the. Let's start with the basics. This is kind of what I do when people come out for training. Just to give you an idea, you know, in case you don't understand the shape of the wheel, how all of that is created. You know, the unique thing about clipper blades compared to like shears and knives is we're trying to lap the shape of the wheel into the blade. And the wheel is cut at a taper. This is an extreme version. And what you have there is a straight line this way. The wheel is straight this way, but 90 degrees to center line, it'll rock. So you have a sharpening blades. You're hollow grinding in front and back, but you're straight across the line. So if this was the comb, this is the cutter, you end up with a hollow grind that allows all the teeth to touch all the way across. So that's the basic thing we're trying to achieve, besides take enough metal off to get them sharp. On a clipper blade, we don't have the luxury on a shear or knife to address both sides. We're just grinding the bottom of the blade. Half the cutting edge is that surface inside the teeth. So you have to go into the body of the blade far enough to get past that dull radius to create that sharp apex for everything to sharpen. So you need to take enough metal off, which on an average about 1,000 material. And so you have to have a general idea of what's going on when you're sharpening based on the size of the grit you're using, the blade you're doing, how much pressure, how fast your wheel is moving. And then after you've done the grinding, inspect the blade for sharpness, and then test it on the test plate to make sure you achieve that uniform shape so that all the teeth.
Okay, talk real loud.
All the teeth.
Can everybody hear?
No?
What?
Okay. I'll crank it up a little bit. So, what I'll do is just show how I charge the wheel, grind the blade, I'll measure it before and after so you get an idea of what's going on as far as the amount of metal we're taking off. And I usually do all this with the lid on for safety, and cleanliness, but I'll leave the lid off so you can see what's going on better. So I think I have 320 grit on here. I was doing 5 ones. So say I've done my 6 or 8 blade sets or 5 blade sets, what have you, on the grit charge. You want to clean the wheel off, and the way we do it, we have this cleaning tool, we call it. Holds a paper towel, and the reason we came up with this, you know, because you can just wipe the wheel off with the towel in your hand. but you have the pressure points of your fingers. We wanted to have nice even contact all the way across the lapping surface and lift that debris off. So no matter which way you're cleaning your wheel, just keep in mind that you can wear the wheel out. If you're cleaning it with it spinning, you clean it with it spinning real fast, and you have a paper towel and you're going like this. I'm going to get this thing clean. The minute you pick up grit, you have a piece of sandpaper and you're basically sanding the wheel, polishing it. So I like to use the wheel spinning, you know, to make it easier and faster, but you don't want to abrade the surface of your wheel. I've had guys, you know, wear the wheels out prematurely, more from cleaning than grinding blades. So that's the reason for this. So I've taken it off. Our adhesive is a water-based or water-soluble liquid, so it cleans off with just plain water. And so I throw that towel away, put another one on. And I have denatured alcohol. I'm going to get the rest of the grit off, and it's also going to dry fast, so that my adhesive will stick to the wheel well. I put a measured amount on the wheel and spread it out. So this is, I call it the lapping solution. It's the adhesive for holding the grit on the plate. Now, it's not what holds the grit during the grinding. It just keeps there, it makes it stick so it doesn't fly off. The mechanical holding power of grit is, the reason we use aluminum is because it's softer than steel, and when you put grit on there and you impact it, it's going to slide a little ways and it's going to burrow into the surface of that soft aluminum. That's the mechanical holding power of the grit for grinding. Now as that moves, and the reason you want to recharge your wheel often and keep the fresh sharp grit on there is so that the grit is sharp and it does bite into the wheel and it becomes stationary.
How often?
You do. So for instance, if I'm using, say, for instance, 240 grit and doing A5 blades, I'm going to do 6 blade sets.
Okay.
Is that what you were asking? How
Yeah,
many?
yeah.
And you know, it's still grinding good at that point. If you use 180, you know, it's grinding real well at 6. You know, you can do more maybe. 320, you're going to do less. You want to stop using the grit charge while it's still grinding decently and taking a decent amount of metal off. For the sake of having consistent results on all your blades. If you exhaust every grit charge, you're pulverizing that grit down to a talcum powder, and at that point it's not biting the wheel, it starts sliding. You start reversing the process.
But is there
you're
a
gonna
comfortable number that you have, sweet spot, where you're like an 8 or a 10? It's always...
I'd recommend 6 with
6.
240, a couple more with 180. You know, it depends how long you're grinding. You know, you see people that, you know, sharpen real quick, and they look and it's, you know, they have a complete grind, it's shiny, you know, and they, well, it's done. Well, it's not necessarily done because you haven't necessarily gone into the body of the blade far enough to get sharp. So it's all about metal removal. You know, how much metal can you grind for grit charge? And you know, depending upon how much you're taking off each blade is going to.
How often do you need to resurface the wheel?
So on our wheels, on an average, you get about 1,000 blade sets per side.
Per side.
Yeah. But some guys get twice that, 1,500, 1,200. It varies. But yeah, when a blade is new. So you have that. Whoops. We have that sharp apex point to the blades, and when they're used, that edge gets rounded, and to get past that it's typically about 1/1000th of material. Get past that, you can get a complete grind on the bottom of the blade, and it looks good, so shiny, but it's not necessarily completely sharp. So it's nice to know how much metal you're taking off when you're grinding the blades. But still, one blade may be sharpened 1/1000th, the next blade may need 3/1000, so it gets down to like anything else you're sharpening, knives, shears, you have to look at it, see if it's sharp. I look at the cutter, the most fragile part of the cutter is that absolute point, that's what does most of the cutting, and so to determine if I've got it sharp, I'm going to look at all the tips, make sure there are not any rounded silver points point back at me. The combs, they're not real fragile. You just need to get that cutting edge sharp. You're not looking at the points; they need to be dull actually.
So it's the cutter that needs to be 100%.
Yes, yes. That's how I determine whether that blade set is sharp. If I ground that blade set long enough based on how dull it was to begin with, I'm looking at the absolute tips.
What happens if they chip the wee bit of it? What happens if one of the teeth is chipped?
It's a judgment call, it's like, oh, I'm gonna have to grind half this blade away to get past that chip. Sell them a new cutter, or do I just, they probably won't even notice it because it's chipped and it is sharp. It's not shaped right, but it is sharp. It's kind of a judgment call. Yeah. Depends on the customer and this and that. But yeah, typically, rule of thumb, if a tooth is chipped, replace it. If you can't grind past it, to be best. On the combs, you want you don't want the outer edge of the combs to be sharp. Is that what you're talking about? Yeah, you would never do that to the cutter, but you want to dull those piece of paper, flat holes, or something like that. Yeah, when the blades are new, they have a nice radius on the outer edges and across the tips, and we grind that away, and you end up with a knife edge on the outer edge of the blades. That can
cut the dog.
The animal. So you want to dull the outer edges once you're done grinding. So let's take this blade here.
Are you demoing your machine?
Trying to.
I have some groomer blades if you want to use mine.
You need sharpeners?
Yeah.
Well, afterwards, you can come over and you can sharpen them yourself.
I can sharpen them myself. Well, they're not going to cut.
Probably will, but
Oh, because that's the automatic one. Okay.
I'll let you sharpen this one. Okay, so I'll get you 240. It won't be as dramatic as 180.
Yeah. It's a tricky.
This is our method of applying the grit. You can sprinkle it on however and rub it in with a pad. We developed this grit spreader, has a little motor, vibrates so that it comes off. I have this spinning about 175 RPM and have the light so I can see when I pull the trigger, hold it back, it just comes off across the whole wheel.
Snow on the set.
Pardon?
Snow on the set.
Yeah. At this point, I just have an even piece of sandpaper grip. So it's just laying there, stuck to the adhesive. It's not set into the wheel. So to set it,
You don't need to rub that in? Or?
I don't. I set it with the impact of a scrap blade. Typically, when you sharpen, you're going to set heel first, but I'm going to go opposite. I'm going to drag the tips. That lets the grit get underneath the blade. So as it's coming up to speed, go back and forth real light, just to level things out. in case they were uneven before I set it. Then I'll do a couple pounds, and then I'm ready to sharpen the blades. So,
Do you tilt it? You come in and then flat?
well, I stayed up. I never dropped the heel down. I want that wedge area.
Got it, but
so
at
you
first,
can-
but then if you work to sharpen it, you flat.
Oh yeah. You wouldn't use that. You wouldn't
This
do
is
that.
just this is.
That's
You
just
were
the-
just doing the-
I've ruined this blade.
Okay.
Yeah.
I was gonna.
Yeah, no, this is
Don't do that.
Yeah.
I use this blade just for doing that.
Gotcha,
This is
gotcha.
like a blade that has broken teeth. I'll use this until it's like this short. And then I throw it in, I grab it, and then I get another use for it. It has teeth on it right now. So it works out. So the way this works, when you're hand sharpening, you want to stay in line with center line. So you can have a laser, or we just have a physical guide wire as a reference. Rule of thumb on any blade, you're wanting to center the cutter over the center of the wheel. So you're straddling the center line of that crown. You want to, when you go back and forth, you want to stay straight. You don't want to be swimming around. The comb is centered over the center of the wheel in relation to where the cutter rides on it. So if the center of the wheel is going through the cutter right there, you're going to want the center of the wheel through the comb. That way you're doing the same hollow on both halves for when you made them together. So this is going to, with the mechanical arms, take a lot of the human air out of it, or possible human air. When you're grinding these blades manually, it's real easy to set down crooked, get a facet going, and you're working your way across the blade or what have you. These pivot every which way. The blades mate right to the plate. Have a predetermined amount of pressure. The pressure is the same. So that's a little less than a pound, a little more than a pound. Fire this up. This determines the number of times it goes back and forth.
Is the maximum only 6? 7 units? 6?
Well, you could have it run just constantly. Kick that up. Like if I'm doing large animal blades, I want to run it for a minute or whatever. I kick that up.
Be careful.
You're not
Just make sure you
resetting.
remember to lift it back up.
Yeah, you can't forget about it.
Come back. Where's it gone?
So during the time that this is sharpening, I can be taking another blade set apart, cleaning the last set I did, where you can utilize this time. It gets the end of the cycle, it'll get that in and pick up. At this point, we want to make sure we have a complete grind. In case of the cutter, I'm going to make sure all the tips are sharp. They are, then I'm going to do my rub test, but we measured this one before around it. I took about 1,000 off. See that? So that one's fresh, 240. It's gonna, by the 6 blade set, it's gonna be taking 3/4, close to a half thousand. Now when you grind blades, you are throwing sparks. The bottom of the blade gets warm first, so the blade does warp a little bit. It varies from all the different blades, so it's kind of nice to be aware of that. Just so when you rub a blade on the test plate, you kind of realize why you're seeing it.
Generate some.
Nothing wrong with this.
See if I have. So getting back to the crown of the wheel, you know, in 1 inch distance, it's carving into that blade about 2/10 of a thousand. Less than 1/4 of a thousand. So not very much. Good blade here.
Well, again, I'm gonna
Try to get this. So it's kind of amazing how much these move from the grinding heat.
So, really,
What do you have right now? When I go to dinner
Okay, let's see if this one will move or not. The way I got it set up. But when you start throwing sparks, the bottom heats up a little bit. Now this is intense. From 0 to 1 is 1,000. So each mark is 1/10 of a thousand. You see it move a little bit that quick. So when you start sharpening, that blade bows a little bit, and so you grind the center out a little bit more than the outer edges. That's why when you rub, you see that arc, that's what that represents. Which, you know, some blades you want, some blades you want minimum, but that's what causes it. It's not the shape of the wheel creating that arc, because if you truly represent the shape of the wheel, it should be straight across. Right. I'm not saying that's what you want. I mean, it's just the wheel is crowned this way, not this way. So you understand. So this blade that was sharpened, it got warm from grinding.
see what they get. Run with the cube.
I put 2 fingers right in the center, kind of in between the rails, front to back, kind of simulate where the spring is. I'm going to push at least 4 or 5 pounds. So it burns it good. So, I don't know if you're going to be able to see this. I'll rub the gippets out like so it shows up good. But you can see how it's burnished there, and a slight arc. Same with this.
Everyone else is talking.
That's all right. You having trouble hearing me, Reed?
I'm good.
Oh, okay. All right. Oh, you guys can crowd around wherever. Okay, so you see that? So if you watch that blade when I first set it down, you're going to see sparks coming up primarily off the outer edges. And that just represents the shape. grid from the heat. Grind this guy, right guy. Okay, so you can see the sparks right when I set down. On the outer edges because they're lower. So if I was doing an adjustable blade, for instance, where I wanted a 5-in-1 or a barber type blade with a lever on the side where I don't want that bowl-shaped hollow, you know, I should flat grind this, but if I'm using the standard
Is that
wheel,
flat grind, is it? The bobbering one is a flat grind?
on this part, the cutter is then I'm going to want to minimize that bowl-shaped hollow. And the way I'm going to do it is either turn the machine down or both. I'm going to kiss the plate until I see sparks all the way across that blade in a breathe. Then I know the blade matches the wheel. Then so if you're doing all the different types of blades on the tapered wheel and hollow grinding them, if you have an adjustable blade, which is designed to be flat ground on the cones, you can have the best results possible by minimizing that bowl-shaped hollow by getting rid of the heat distortion in the grind.
Does this machine sharpen 5-in-1 cutters?
Yes.
It does.
So now you see how that's straighter than it was. Now it's just the blade. Yeah, so there's less. Yeah, the closer you get to the center, there's more crown. I'm done. Wrap it up. Okay. So, what would you like to see? You have any questions? Yeah.
What about the blades that have a ceramic cutter?
Oh. I have a diamond coating I put on the wheels if I want to sharpen on the machine.